So, firstly, I'd like to acknowledge the traditional owners of country, the Gadigal peoples of the Eora Nation, upon whose land the University of now stands. Would also like to pay respects to elders, both past and present, acknowledging them as the traditional custodians of knowledge for this land. Thanks everyone for joining us for the final National Science Week lunchtime talk at the Cape Bowling Green Museum. I'm happy to introduce our talk for today, Collaborative Conservation, Case Studies in the Shared Care of Museum Objects by Nick Flood, Senior Conservator at the Australian National Maritime Museum. He's never more at home when his hands are dirty. As Senior Conservator Special Projects at the Australian Maritime Museum, he is frequently up to his elbows. Nick has conservation expertise in metal, functional objects, maritime archaeology, and photographic documentation. And thank you, Nick. Now over to you.
Thanks, Lorraine. Welcome. It's the last session of the National Science Week lunchtimes talk here at Cape Bowling Green Museum. My name is Nick Flood. I've been working in conservation for about 15 years now. My background is I have a Bachelor of Science, Bachelor of Arts in chemistry, with majors in chemistry and European studies. I studied towards that at the University of Adelaide. And part of my time there, I took a semester abroad at the Leeds University School of Chemistry. There, it was, for me, a combination of an intense period in study in chemistry, as well as all the tourist action I did as a young tourist in Europe, seeing historic sites and galleries. That really consolidated my direction into cultural materials conservation. On my return, I enrolled in a Masters of Cultural Materials Conservation at the University of Melbourne, and I specialised in three-dimensional objects. That might not mean much to you now. We can talk a little bit more about that later. In my working life, conservation has taken me across Australia, New Zealand, Southeast Asia, in both public practice and in public institutions and private practice. I currently work as Senior Conservator Special Projects at the Australian National Maritime Museum. Let me just change this. At the Australian National Maritime Museum, Darling Harbour, and out of hours, for a semester each year, I'm a casual academic at the University of New South Wales School of Art, Design and Architecture, where I teach in a course about conservation and registration. Today, my aim is to share 3 case studies with you, 2 from the Australian National Maritime Museum and another from outside. And another from outside this institution. And I'm using this as a way to demonstrate how conservators work with other professionals to achieve high quality results. These others include scientists. I've included scientists not just because it's Science Week, but science and scientific knowledge and practice is core to what conservation does. But I've also included work I've done with engineers and other allied professionals. I'm aware that not everyone is fully aware of what materials conservation is, and some people may be new to this profession. So let me give you some basics about conservation, the Australian National Maritime Museum, and the nature of collaboration. Here are some stereotypical images of a solitary conservator painstakingly working at the restoration of a painting at an easel in a laboratory away from the eye of the public. The reality can be a little different. What a conservator does in simplified terms is they preserve objects that have cultural significance. This is done by either a preventive approach, where the aim is to stop or slow deterioration by establishing a safe environment for the object. There's also the interventive approach, where deterioration and loss are treated by direct chemical or mechanical means in order to stop active degradation or to restore losses that might impair the function of an object or the interpretation of an artwork. Within a museum setting or a gallery setting, tasks often include assessing and documenting an object at the time it's acquired into the collection, and then throughout its life. Documentation can include written reports and photography and imaging. Work's done to prepare objects for exhibitions and loans, and recommendations are made for display requirements and storage requirements of each object. The identification and management of hazards within collections is an important part of the role also. I mentioned that I specialised in three-dimensional objects, but there are other specialisation groups. Paintings, paper, books, photographs, textiles, and preventive conservation are all specialisations within the field. A conservator, in order to do their job in an informed way, requires an understanding of significance. Significance is what makes something culturally important. That could be social significance, artistic significance, historic significance, or scientific significance. They need an understanding of the materials and techniques that have been used in the production of an object and the deterioration processes that affect those materials. Conservation works within the constraints of an ethical approach that aims, simply put, for the minimal intervention in the physical objects, and when intervention does occur, it can be reversed. That said, many contemporary artworks and functional technological objects challenge this ethical approach. The stereotype would say that a conservator works away from the public gaze, but I actively do a lot of work to promote my work to the public. The public is genuinely interested in what happens behind the scenes at museums and galleries. And some of the projects I work on require moderate to large amounts of funding and resources. The more that I can justify what I am attempting to do through public interest in those projects, the more resources I have to do my job well. The background to conservators, the conservators have individually varies quite a bit. Today, most training in Australia is by a master's degree, and it attracts people with a background already. So these could include studies and experience in science, archaeology, history, or the fine arts. The Australian National Maritime Museum is a federal institution, so it's run and funded by the Australian federal government. It opened its doors in 1991. It has the mission to engage, educate, and inspire Australians about our nation's relationship with the seas and our waterways. It's a modestly sized museum with approximately 120 staff. It has about 150,000 objects in our collection, and these range in size from a silver coin recovered from a shipwreck, all the way up to a lighthouse. These are all in our collection. You can see from this video probably what makes the Australian National Maritime Museum unique internationally is the large number of vessels floating in the waters of on our waterfront. What the video doesn't show, however, is that we have a gallery building, and that gallery building is full of smaller, more conventional and unconventional collection items. So to go beyond that promotional video, I've got a little snapshot of some of the things that make up our collection. And these range in object types and materials, from paintings to photographs, to books, to paper, maps, charts, maritime archaeological recoveries. We have quite an extensive collection in that area. Did you know that it's estimated that there are 8,000 shipwrecks in Australia's waters, and many of those are yet to be found. There are unexpected items here that, you know, the layperson might not expect to see in our collection, and they could be hazardous pharmaceuticals used by ship's doctors, functional objects. Down the bottom left corner is the triple expansion marine reciprocating steam engine from a Sydney Harbour ferry that sits in the centre of our gallery. That's a functional object. We've a great collection of Indigenous artworks. Centre bottom is a bark painting. This is one of a series of 47 bark paintings used by the High Court of Australia to confirm traditional ownership of the Mud Bay, the Blaeu Mud Bay region of northeast Arnhem Land. This sort of diversity in a collection is pretty common within collecting institutions. So it's no wonder to me that conservators choose to collaborate with other professionals to achieve the best outcome for the objects in their care.
Do you have those more contemporary, the Indigenous artwork, or the?
Yeah, we do. I'm
curious what the oldest piece in the whole.
Yeah.
Maritime Museum, I know what it is. Do you know what it is?
I suspect we're going to see one of perhaps the oldest object in our collection. Our collecting practices in the Indigenous area are to collect contemporary examples of Indigenous objects rather than historical objects. And I think we can avoid like some murky ground in that area by that decision.
I love the beautiful bronze sculpture you have in the exhibit.
The dugong, the large bronze fish. Yeah, that's probably only 10 years old. Yeah. I think the beauty is in choosing to only collect modern examples. We avoid some of the problems, but we're also stimulating an arts industry. I think.
Yeah, I just want to get off the topic. Another exhibit across the hall, Dr. Paul Connolly, is that his name? I went to one of his talks last week, and he mentioned in one of the items it was in collaboration with Monaco, the print, and I told him about the work at the moment. You haven't gone recently, Joe.
Yeah. But
it seems like a pleasant symbiosis.
Yeah.
When you do the round a bit, which I like to do between Australian Museum, Maritime and here, there's a bit of a thread, a common thread.
Yeah.
And that a lot of the staff aren't aware of it. Thank you. Last question.
Sure.
Your conservation and archaeology, whether you want to do it on land or water maritime, do you always start with the one course, or do you do it different one for maritime archaeology?
For in Australia, it's just the one course primarily. There are training programs that deal with conservation of maritime archaeology elsewhere, okay. But that's quite a specialised area.
Yeah. Thank you.
No worries. So to talk about collaboration and working in a collaborative group that crosses disciplinary, national and cultural borders, it has the benefits that many minds are harnessing a diversity of experience and expertise that can bring about success in a project. There are, however, challenges that can arise from collaboration. Collaboration brings many different perspectives and technical languages and customs that can cause problems with communication, and establishing group norms can take time and effort. Divergent points of view can cause tension, and there is the temptation to smooth out tension, to diffuse that tension. But if used properly and managed well, that tension and that disagreement between parties can kind of, that friction that results can spark creative and novel solutions to your problems. It's a two-sided coin though. It needs to be managed well, but that tension can be a positive thing. Communication difficulties can be resolved by defining key terms and drawing up clear aims. And this, in a scientific scenario, that would be through research questions. In more of a project-based collaboration, it might be by establishing a scope of works document and similar types of documents. I'm going to elaborate now on 3 case studies where collaboration was really important to the outcome. The first is the investigation of the Blaeu Celestial Globe. The Blaeu Celestial Globe was made in 1602, so it's possibly, I'm reluctant to say this with any confidence, but in my mind it's the oldest object within our collection. It's a celestial globe. So most globes are terrestrial, they're a map of the Earth, where this is a map of the heavens, of the constellations in the sky. And you can probably see there are recurring little marks and points. They're the individual stars in the constellations. And around that, the mythological understandings associated with those constellations have been applied on printed paper and then coloured afterwards. This globe was made by famed cartographer, Dutch cartographer, William Blaeu, and it's thought to be the only surviving celestial globe of this size in the world, from this era in the world. It was collected by the Australian National Maritime Museum. Why? That's a question that I have asked myself, and we bought this object. It was quite an expensive object because it was one of the first celestial globes to properly chart the constellations of the Southern Hemisphere. So that's quite important to us here in Australia. It was requested for loan by the State Library of New South Wales, and this was a chance for a new team of conservators at the Maritime Museum to examine and document this object in a way that hadn't happened before. Our research question that we came up with essentially is this object structurally sound and is it suitable to travel? Yes?
I was at the State Library last week for the Shakespeare 400th anniversary. That the theatre was called the Globe, wasn't it? Anyway,
Yeah.
Is that a permanent, is that on display or it's in the archive for safety?
This object, this is the Maritime Museum.
Oh, so the SL.
Yeah, the Maritime Museum, the State Library requested to borrow it for an exhibition they put on. I think
current or was this a while ago?
I think it was 21, 22.
Okay.
Yeah. So the construction on the globe, it's made up of several parts. So there's a wooden stand with 4 legs, and that's attached to a wooden horizontal ring. That's the horizon ring. It's on the top surface there is printed paper that's been adhered to that surface. There's you can see looping the globe there is a meridian line, and that slots into 2 parts of the horizon ring, probably at 2 o'clock and 7 o'clock, as you see it. That's made from metal. a copper alloy, most likely brass, and that's the meridian line holds the globe in place. The globe can pivot within the meridian line, so it can spin, but there's some deformity there that probably means it's not such a good idea to spin the globe without taking too much care. The globe is made, they were typically made, our research shows they were typically made by paper mache, to which you apply a coat of plaster and you smooth and model that coat to get the spherical shape you want. And then again, you apply printed paper with a particular shape, so that here's an image from the exhibition at the State Library that shows gauze here, where it's a shape which allows flat planar paper to be shaped to take the form of a sphere, and our globe uses the same approach. And you can see on our globe, you can see those gauze, and you can see a bunch of other stuff that basically the description that I've described has come through my visual understanding of the object by direct observation. That doesn't give us the full picture. So visual examination is great, but when it comes to the internal structure of the globe, it's especially, we went to the Sydney Imaging Corps research facility at Sydney University here at the Charles Parkins building. They, in amongst other things, they have CT facilities set up primarily as an operating theatre for human and veterinary surgery. They do have gaps in their schedule, so they were quite happy for us to use some of their time. And here's a photo of me carefully placing the globe on the operating table. We image both the globe and the stand. So you can see up in the background now, I'm in a separate room because the machine's running. I don't want to get exposed to radiation. The stand's off in the background, and I'm observing the screens as this model is being developed. So a CT scan or computer tomography combines hundreds of thousands of X-rays to build a three-dimensional model. And we're going to look at some of the various renderings of that model. Here, you can see this is a rendering of the surface topography of the globe. And it shows that the gauze, and it shows some cracking around the edge of those gauze. But I can look at the object myself and collect that same information. What's so special about this image? Well, this image has removed all of the colour and surface decoration from those gauze, and now its form and surface texture is a lot more easy for me to take in and interpret, and perhaps make judgments and observe patterns and do some higher level thinking that my head just doesn't have room for if it's overcrowded with colours and designs and inscriptions, etc. This here is the same model, so it's a three-dimensional computer model was built, but this is a rendering of the cross-section of the globe. And what we can see, this is in the form of you'd interpret this as the same way you can interpret a conventional X-ray. So on the outside of the globe, we have air, and it's showing, well, the image itself shows different shades from like a mid-grey to a white. The whiter the features, the more dense they are. That's how this is to be interpreted. So the air outside is a mid-grey. There's a metal, our meridian ring is metal, and it's showing white, so that's quite dense. And you can also see there's an orange line running horizontally, and that's catching two large long features. And that's probably, they're the pins on which the globe rotates. But I mean, we're looking inside and we're looking at this X-ray, it's showing us density of the features, but I understand that information from just looking at the object myself. I can see the horizon band, I can see the pins on which the globe pivots. But going further, the volume inside the globe primarily has the same mid-grey and the same density as the air outside. I can pick the globe up and my guess would be it was hollow. That's been confirmed here by this density. So there's evidence to support my intuition that the globe itself is hollow.
What did it feel like holding the soccer ball?
It's probably the weight of tub of margarine, so 500 grams. It feels surprisingly sturdy, but I mean, just picking it up, you don't know what's going on inside.
When was it you actually did the X-ray? Like a few years ago?
Yeah, I was wearing a face mask. It would have been 2020, 2021, around then. There might be a date on this image here. Not that I can make out. All right, so we can see it's likely that the globe is hollow. Across horizontally across the middle of the globe, there's a shape, and that shape is it has the density somewhere between metal and fresh air. So it's denser denser than air, so it's likely something's there, and it has a kind of a linear pattern to it. So our interpretation there is that there is a structural component. That component's made from wood, and there are 4 smaller pins that fix that structure into the globe, into the shell of the globe, and we can't see those. They're covered by the heads of those pins. Are covered by paper and the gauze. Now everything looks fairly well intact. I think we're feeling a bit more confident about that. We feel more confident about the condition of the globe.
It's a 14.7 half or the full?
I'm not sure actually.
But is that the 14.7? Is that the whole width of the half?
No, that looks like it's the
Is that 14.7?
it's top, no, millimeters. So it looks like we've got the core at its smallest. The structural center is 15 millimeters. Yeah. And here, just to show off, here's a rendering of the model, and it's been made to turn. I mean, it looks great. It looks impressive. It's good to promote this sort of thing to the public. But what this does, we've gone from static images, now we're moving images. It lets us perhaps join some dots that might be there. It's a tool that might help us identify patterns, or in a more meaningful way, understand the relationships between the different parts of this globe. All right, so we feel a bit better about the globe. The stand, on the other hand, is a different story. Here's same again, it's a rendering of the topography of the surface of one of the legs. And it's kind of a crude rendering, but even still, you can see there are, along the main section of the leg, there are a number of holes and blemishes. They can be seen by looking at the object, but again, the leg itself is brown, the holes are shadowed, they're not always particularly clear. So here the colour and there is no decoration, but the colour is gone and lets us kind of play with the locations of these a bit more. We can see these imperfections. This is a cross section of the same leg. And now there's no metal present here. So the sensitivity shows the wood's components its only wood components, range from kind of a mid-grey to a white. The air outside is black. There are areas of the wood that have the density of air, so we can assume that they're voids. And it's most likely that these voids are the result of a wood borer beetle. So a wood borer beetle is an insect that'll lay its eggs on imperfections or cracks in wood, and the eggs will hatch. A larvae will tunnel into the structure of the woods. It'll consume the timber as it grows and settle somewhere beneath the surface, waiting for the right conditions. When those conditions come about, it will eat its way out and fly off and continue the circle of life. It's the same leg, just seen from a different cross section. So cutting the leg this way. We feel good about the globe. We feel a little less certain about the conditions of the stand. Work continued on this object to help document what we had. Perhaps slightly aside from the research question that we had, but we continued documentation. So we have here Michael Rampey from Macquarie University. He's pioneered and become an expert in a technique known as photogrammetry. So photogrammetry, it's an imaging technique where multiple overlapping images of an object from all different angles are taken. They're fed into a piece of software and a three-dimensional model is produced. Here, Michael keeps his camera fixed and his lighting fixed, but the object itself, he spins it on a lazy Susan, and bit by bit he collects images. And this method of capture was done both on the globe and the stand. Michael also took a structured light scan of the object. I might not take you into how this is a still of the model. I might not take you into the actual way to play with that. But with your mouse, you can rotate, manipulate, and move this object. It gives you a chance to kind of investigate the object in a digital form with quite high resolution. It's the first version of this model where the globe and the stand have been united. It's quite useful for documenting the condition of the object. We could annotate this model if we wanted for conservation purposes. It's also, with documentation, it can be quite difficult to communicate everything efficiently with a written word. And photographs themselves, they can help overcome some of that difficulty. But photographs have limitations too. So models like this are starting to feel that need. In a way that perhaps lets us visually reason with things or communicate visually. Also, it's a great way for the public to get access to this object. This object's fragile in a number of ways, so it's really probably only conservators with a good reason that would get their hands on it. But now the digital object, people can play and check have a look for their star sign. They can engage with this object in any way they see fit at no risk to the object. There is a plan that would let us spin the globe itself within the stand, independent, so the globe would turn independently of the stand, giving you that, that function that this object would have had back in 1602. And here, the model lets you play with light settings and surface finishes. So I've removed all the colour and I've adjusted the lighting to emphasise the gauze on the globe here. Another other imaging technique we have, we use it in-house at the museum, is reflectance transformation imaging. Emma and myself here, you can see my stripy socks. We're imaging a punch bowl. We're going to talk about this object later on in the year at a conservation conference. But we made some great discoveries with this imaging technique. This time, the technique differs from photogrammetry. The camera and the objects stay in the same position, they're fixed. But in my right hand, I have a flash, and I'm walking around, moving around the objects and taking a number of different images. Emma and I are making sure that the distance from the flash to the object remains the same in each image. But typically you get about 48 images. You combine them together in a piece of software. And that software, so right here is a little black sphere that I've placed on the object. That stays stationary as well. What the software does with each of the 48 images, it detects the angle of the flash just through its reflection in that sphere. And it creates a model where it's similar to a photograph, but each pixel has a value for red, blue, green, and a normal value. So a normal value is basically a value of the perpendicular of a surface. So it makes a judgment about that based on the reflection and the shadowing from each of those 48 images. It's an excellent technique for revealing fine-grained images. And here I've got some renderings of it. To be honest, I might skip over this slide. But these are all renderings, even though some of them look like photographs. They're renderings where I've adjusted settings to take it from what resembles a visual photograph. I've removed some of the color information and exaggerated some of the reflectance. It gives me a better understanding of the surface. And then I've removed all color values here, and I'm just displaying normal values with a false color. You can see here's the little black sphere, and that might give you an indication. It'll let you judge based on the color of the image what's happening if a surface is concave or convex, or what's the orientation of the surface at different parts of its slope. All right, so in summary, what can we say about the globe? Is the object structurally sound and suitable for travel? The globe appears to be, the stand less so. So our effort would be dedicated more with a high priority towards the stand. If we were going to let it travel, we'd have to overcome some risks associated with that, some heightened risks given the new information we have. And we've now collected a bunch of images using different imaging techniques that has aided our documentation, and it's helped us to understand that this will help us understand the stability of the object. When we come to visit it later, we've got all these resources in place. This could be me in 5 years, or it could be one of you guys in 20 years. How can the information that we have now be transmitted to someone in the future? These are tools that help us with that.
I don't know if I'm catching the difference verbatim, but that little triangle is that originally intact, or there's been
so that's a
bit that's been modified?
Exactly, yeah, well spotted.
The chart itself, the special software, but then something got done 100 years later, 15 years or something. Not
using this technique, but you're right. It is an area of previous repair, and there are visual signs. Like if you look to the left, that area has none of the inscriptions that are widely all over the printed paper on the horizon band, and the markings don't quite have the same regularity as the original. So it's likely that small area of repair was done by hand using drawing tools. Did an amazing job. I'd be satisfied if I'd done it, but still there's enough there to tell you different methods were used, and it's probably by a different hand.
I'm just curious in today, technical or with your...
Certainly with other methods.
pick all the, not anomalies, but differentiation, or is that too sophisticated?
For this technique, it's certainly too sophisticated, yeah. So moving from a celestial globe of the heavens to a landscape painting. This is a close-up of a painting. It's not held by the National Maritime Museum, but it's a project that a paintings conservator and myself have been interested in and are working on, and have been doing so for a number of years when we can. So it's a landscape by Scottish-born Australian painter William Frater of the Flinders Ranges in South Australia. It was purchased by a private collector at auction, only to find that in a certain light, the back of the painting shows unusual patterns. The prospect that there was another painting on this canvas on this board was quite a tantalising thing to look into. So looking at it with your naked eye, you can see certainly there are areas of impasto in the paint, so thick areas of paint that vary across off the surface of the painting. That there may be a sketch of an incomplete painting with at least one figure. We used reflectance transformation imaging, so RTI, to help answer the question about what is actually there. So, right, here's the front of the painting. Here's the back of the painting. We've still got the frame in place. Now, this is just a photograph. You can, if you used your imagination, you might be able to find a figure there. But I included this as a way to say photographs, it's a form of visual communication, but they're not always fantastic. I've now got an image of an overall photo, an overall screenshot of an image taken using RTI. And bearing in mind, this painting is probably this big, and RTI's strengths are on the smaller scale, but still you can see a standing figure just off to the right of this painting. And that certainly it gave us some hope. We then used RTI on a smaller scale and focused on different areas that you can see with close visual investigation using light at an angle. You can get hints at like certain curves or straight lines, but it's hard to get an overall picture of an individual figure. So we concentrated on different areas, and we were able to resolve more details than we could just using raking light. Is light held at an angle to exaggerate shadow. So what our conclusions was it looked very similar to another painting that William Frater had done, primarily based on this standing male figure. And what we did is we thought this may be a sketch, an unsuccessful sketch of this painting. And it was unsuccessful perhaps because the feet and ankles of the main character have been cut off from the canvas, so it wasn't composed properly. And maybe the composition varied in some other ways. This is the conclusion that we came to at the end of RTI. But thankfully, recently the instrument manufacturer Brooker ran a series of 2-day workshops at the Art Gallery in New South Wales to demonstrate a new instrument they have. It's an M6 jet stream. It uses a technique called X-ray fluorescence, where X-rays are used to excite atoms that then re-emits that energy with a lower wavelength in a way that's characteristic of each atom. This machine itself will work from sodium to uranium, so it doesn't capture information on all elements present. But it works with such speed and power that it's able to create maps quite quickly of two-dimensional surfaces. So what we did is we put our painting, the back of our painting, on the stage, and elemental mapping was run for about 5 hours. And it only captured a small, well, it didn't capture the complete area. We were too our painting's too large, but it's roughly this area, an area that we've got interest in. And the results showed, okay, these maps of that area, and it shows basically uniform levels of lead and levels of iron with perhaps the evidence of brushstrokes in there. So the interpretation that was given from that is that lead-based white paint pigmented with possibly Prussian blue was applied over the surface of our sketch. Now that Prussian blue is perhaps gives our paints, our top coat, that grey finish that it's got. Looking more deeply though, this technique is able to even though we have a thick layer of lead paint, we're able to get information of the elemental makeup beneath that lead paint, even the lead levels beneath that paint. So a higher energy lead peak was able to, the map resolve some of the figures. We've got a map here of both lead, a white pigment, but also zinc, a transparent white pigment, is able to give us more than just their location, but it gives us an image of this painting.
Just want to ask a question I didn't quite understand earlier. When it had verso, is that the region, the canvas?
Oh, verso just means the back. What? When you're talking about paintings, the verso is the back of the painting.
Like reverse.
Yeah, exactly.
Like reverse.
Yeah. I guess the back of a coin is the reverse. No worries. But beneath that thick layer of lead paint, lead over paint, we get a range of other elements showing up. So we have titanium, barium, iron, manganese, chromium, copper, cobalt. Now this is evidence that this painting that was overpainted was probably in a well-developed state. You've got a range of pigments that have been applied to the board. Now we can combine some of these pigments together and apply a false color, although the false colors chosen here are probably somewhat accurate. So zinc, we said it was a transparent white, it's been given the white. Iron, here is red, which could be red or brown as a pigment. Chromium can be a range of colors, but we've assigned that green here. So that starts to resolve some of these images in a way that perhaps like to interpret what that painting was. There are some better ones here. Probably the best here is just this is just of zinc, and this is a heat map, they've called it. So ranging through from black to white, but through yellow, orange, red. Yeah, and what we can see here is we can see the standing figure in the foreground with legs apart. We can see the back of the standing figure in the background. The crouching figure to the left, perhaps their head is facing more towards the viewer than we had thought. Two arms in front of body and a knee. Crouching figure to the right, we have what looks like an arm, an upper arm and a forearm and a knee. And
I'm actually seeing a skull, but I don't think anyone else can see it.
Oh, maybe a little bit.
The top.
Yeah.
Profile.
So what we've done is we've reevaluated our conclusion. So our interpretation previously was that there was a sketch of a painting that was discarded, and it probably had figures in kind of this sort of orientation. We did some elemental mapping, and our interpretation is there was a somewhat completed painting underneath our overpaint, but the orientation of the figures are different, and it might resemble something like what you can see here. So yeah, great results for us. Next, I can see that we're running out of time. I'll just quickly run through a major project that I'm working on and continue to work on for the next several years. So it's quite different to the others. It's the conservation management of a heritage lighthouse. This is the Cape Bowling Green Lighthouse. It was built in 1874. Well, it was commissioned in 1874. It was built on a sandy spit known as Cape Bowling Green, about 70 to 80 k's south of Townsville in Queensland. Now, in the early days of the colony of Queensland, as it separated from New South Wales, it was a time of increased trade and shipping, and the importance of maritime safety was well understood. And so this young colony committed to building 22 lighthouses across its coast. It was a huge investment in infrastructure. As a measure to save costs, rather than build the lighthouse out of traditional stone or brick, they elected to build it from a timber structure clad in iron. The timber was a Queensland hardwood, and it's a unique Queensland design. This tower then supported a lantern room and lighting apparatus, which all came from England, from Chance Brothers, and it was ordered out of a catalogue, essentially. So when we think about significance to Australia at the Australian National Maritime Museum, what we value more is the structure and the cladding and the design of those components, rather than things that are found in most other lighthouses. So on the 3rd of October, 1874, the lighthouse became operational. There was a number of changes that occurred to the lighthouse over its life. The most notable was in the mid-1980s. It was decommissioned, and it was replaced by, in its navigational role, by a modern light tower. In 1987, 1987, but I was saying that the Australian National Maritime Museum opened in 1991, but collecting for our museum began a long time before that. In 1987, the museum worked closely with engineer consultants Arup and the Royal Australian Navy to document, disassemble and disassemble the decommissioned lighthouse and transport it to Sydney.
I was going to ask if it still exists in Townsville.
So it's south, it's about 70 k's south of Townsville on a remote part of the coast. I don't think you can get access without the right permissions. But there is a more kind of industrial tower, kind of skeleton tower there at the moment, doing the same job.
Lighthouse is always going to be on the mainland or not?
No, no.
Okay.
Yep. So over several years, the lighthouse was reconstructed in front of our museum on Darling Harbour and opened to the public in 1994. Visitors are able to climb the 87 stairs of the spiral staircase to the lantern room and platform. There, you get to inspect the clockwork mechanism, the numerous flint glass lenses, and you get to take in the best view of Sydney, looking out on the CBD over our floating fleet of heritage vessels. These images here kind of get us a chance to compare some of what we think of as significant. So we think at the museum more highly of the unique structure, the timber structure, but maybe the public is more drawn with the idea of the operating mechanism. Understandably, the maintenance of a building like this is, it's unlikely that a conservator will be able to fully understand all the issues at play. So we involve professional expertise, and that's particularly important because of the risk to public safety that are present here. Most notably, the structural integrity of the lighthouse and any hazardous materials that may be present. We use a range of professions, trades, and paint technicians. We have structural engineers, and they help us to assess and certify the structure. They're able to understand and interpret the building codes and Australian standards in a way that as a conservator, we just simply don't have that expertise. They also help us prioritise the work that we need to do. We use structural engineers from Partridge Engineers, and what attracted us to them is their experience in working with heritage structures. So they understand some of the ethical constraints at play. We also, these are the recommendations that they've made for us in this current financial year. So in amongst other things, we've prioritised corroding and degradation that's occurring on the metal cladding. That cladding, it's not just there as a waterproofing mechanism, it does have some structural role to play. They want us to assess the hold down bolts. So this is the underside of the lantern room, and this here is the light tower. These bolts are dotted around the perimeter of this structure, and that's what physically holds the lantern room to the lighthouse. Now, they all look fine. They've been doing their job and they're probably okay, but we don't understand that properly. We haven't inspected them since 1994. We don't know what bolts were used in 1994, whether they're appropriate, whether they were appropriate back then or appropriate now. They're two different questions. So the engineer would like to understand their condition and their suitability for performing that work. And also, there are 4 windows, open windows in the light tower, and there's a problem with the water tightness there. So water is coming in, and that's fine, but it's leading to the corrosion of the metal cladding, and it's finding its way into the structural timber, potentially causing rot and damage in a way that we don't understand. So we want to stop that water ingress. Just quite recently, we've engaged an environmental hygienist, and their role was to help us understand what material hazards are present. Previously, I think it was 10 years ago, museum conservators themselves took samples of paint, sent it off to a laboratory, got some results back that indicated the presence of lead and a number of other harmful materials. But it's not that simple. How does a conservator interpret those things against certain standards? So just the presence of lead itself doesn't make a material hazardous. How should I re-put that? It doesn't guarantee that a material is classified as a hazard according to certain standards. We don't have access to those standards easily, and we don't understand them. So we've brought in expertise that's helped us categorise and confirm what hazards are present. So for us, it was metals, what metals might be present in the paint that would make them hazardous, and whether there are any asbestos-containing materials present. This is a Chance Brothers catalogue, and the catalogue does describe some of the components of the lighthouse as containing asbestos. Here's the mantle of the burner, and it's basically an asbestos and silk sock that would glow from the flame of the kerosene. But we don't have that component. That's been dealt with. That's an obvious thing. But what we did find is that a lot of the paint present on the interior of the lighthouse is categorised as hazardous because of its lead content, and some of it is classified as hazardous because of its chromium content. There is asbestos-containing material, both brown and white asbestos are identified, but they were found within the gaskets of the valves of the fuel system. So we have fuel tanks. The fuel tanks once upon a time would have driven kerosene up to the burner. Our tanks are empty now, but we still have the valves present. There was both types of asbestos present in those gaskets. The good news is that they weren't open hazards. They were contained within those valves, so there was no risk to public exposure. Work continues on the lighthouse, and we need to incorporate the engineer's recommendations. Additionally, we're planning on repainting the interior of the lighthouse with the extra precaution now that we're confident with the classification of this majority of the existing paint being hazardous. I'm always particularly keen to promote the lighthouse whenever I can, due to the substantial amount of funding required to do our work. We need to justify that expense and that funding in high levels of public interest. So this weekend is the International Lighthouse and Lightship Weekend. The lighthouse will be open all day tomorrow and Sunday. We have amateur radio operators that will be signalling from our lighthouse to lighthouses all over the world. Light ships as well. For those mathematically minded, you might have noticed that next year is the lighthouse's 150th birthday, and it's the 30th anniversary of it being open to the public at our Darling Harbour site. So we're planning some big celebrations. In conclusion, I'd just like to thank the Chalchuck Wing Museum for giving me this chance to share a bit about conservation, collaboration, and the good work that happens at the museum. Don't forget Lighthouse Weekend this weekend. I've got a limited number of free passes here if you'd like to visit the museum either this weekend or whenever you feel free. But thanks a lot. Come and chat to me if you want to pass or you've got a question. Thanks.